body. So we're having a look at these motion questions that are kind of non-SUVAT based, and the way you make that decision is we're allowed to use the SUVAT equations when the acceleration is constant. So there are two things we think about. One, if we've got any kind of force involved, then the acceleration isn't going to be constant or a changing force. The other thing is when there's just not enough information. So in this first question here, I mean, technically we could do this as a SUVAT equation. The problem is we just don't have enough information. So what we've got is a truck moving freely down a ramp. So there is a constant acceleration, a constant force on this thing that is some fraction of gravity, depending on the angle here. The problem we've got is they haven't given us the angle, so we don't know what the size of the force is down the slope. We don't know the acceleration, so we can't really see that. What we can do, though, what we have been given, is a height. So as soon as we've got a height at the top of the ramp, and we have been converted into speed at the bottom of the ramp, that's a conversion of energy. The kinetic energy at the bottom of the ramp is going to be equal to the gravitational potential energy at the top. They haven't told us the mass, but we don't need that. So we can rearrange. We can put our values in. Our height was 8 meters. And that's going to give us a speed, meters per second. We're using the piece of information that's been given, kind of trying to pick it out in the right way. The wordy questions here, the ones that we're trying to explain how things work, how things are going, were generally done really, really well. So I want to focus on these mathy type questions. I'll post the mark schemes just so you can see exactly what you were looking for. So the first question was an energy type question. The second one, well, I've got a collision. Now, this is an elastic collision, so energy is not going to be conserved, so I can't use any kind of energy calculations. But what I have got are masses, I've got velocities, so this is all about momentum. So in elastic collision, energy is not conserved, but momentum always is. Show the speed of the trucks they join together immediately after collision is about 0.3 meters per second. So what we've got to think about is, well, truck A, it's got a mass of 16,000 kilos. It had a speed of 2.8 meters per second. So that lets us know its momentum. Truck B, 12,000 as a mass, speed of 3.1 meters per second, being really specific with my language there. Now, these are our speeds, but we've got to use velocity here. These things are vector quantities, and they're going in opposite directions. So I could pick left or right is positive, but let's go for convention. They're going towards the right is positive. That means that truck A is going in a positive direction, and truck B is going in a negative direction. That's going to be equal to the overall momentum afterwards when these two things are joined together. So if I add together the two masses, and then some speed v, which we're trying to calculate, I can do my subtraction, I can divide it by 28,000, and what you're going to get out of that, if we have a little look, is 0.27 meters per second. What? Did I get that right? So just jumping back here, because I looked on the wrong bit of paper where I've done all my working, right? That doesn't equal that in the slightest. It's going to be 12.5 meters per second. So let's just do that little correction. Checking his own calculators, you don't it's always useful, right? But you can see momentum before equal to momentum afterwards allows us to work out the speed. Part C, calculate the impulse that acts on your truck. Now we need to know that an impulse is a change in momentum. And actually we can link that to a force as well, a rate of change in momentum if we're being clever. But the change in impulse, and the impulse for truck A and for truck B is going to be the same because they've got the same force acting on equal opposite forces, Newton's third law. So whichever one we use, it doesn't really make a blind bit of difference. So let's say I'll look at the change in momentum for truck A. That's going to be the mass times by the change in the velocity. Now the mass is staying the same. If the mass was changing, I'd have to consider the change in mass as well. So for truck A, my mass is 16,000. My change in velocity, well, I started off at 2.8 meters per second. I went down to 0.27 meters per second, so that's my change in velocity. So that means that my impulse, if I put my numbers in, is 4 times 10 to the 4 kilogram meters per second. You can use Newton second there as well instead, but that's kind of our standard momentum type unit. So our impulse and our unit. Now, question 3 here then is kind of bringing all of these ideas together. we've got a pellet fired at a wooden block. They join together and they swing up the way. And our job is to work out the velocity, the speed of this thing just before it hits. But we're missing lots of information. Now, I've definitely got a force. I've definitely got a collision, so I can't use that. And I want to probably use momentum. If I need the momentum of this block just after collision, I know it's the same as the momentum of the pellet, so I can work out the speed. Problem we've got with that, though, is I don't know the velocity of this thing that's just moving, but I do know the height it goes to. So we've got kind of both the calculations we've already looked at. One is going to be using energy to get the velocity here. When I've got the velocity here, I can work out the momentum, and I can use that to work out the velocity there. So, one step at a time. Let's go through and talk about our block. Now, the tricky bit, I suppose, about this question is we've got a pellet on its own, a wooden block of its own, and these two things joined together. So we have to be really careful about which mass we're using at each point. Luckily, if I'm doing what's the velocity of this thing here, well, I know it's going to be equal to the gain in gravitational potential energy up here. So I don't care what the mass is. We know that they're going to cancel out. I can put my values into 9.81. My height was 0.63 meters. Let's square root the whole thing. Well, that gives us a speed of 3.51 meters per second. There it is again. So that's the velocity of this thing just after collision. So let's do our next bit and work out the momentum of the block and the pellet when they've just collided. So my momentum will be my mass times by the velocity. The mass is going to be, well, 0.45 kilograms for my block. I had to convert it from grams, plus the mass of my pellet times by the velocity. So that will give me a momentum of 1.61. So I now know the momentum of the block and the pellet just after collision. Well, that's going to be the same as the momentum of just my pellet just before the collision. So I know its mass. This is going to let us work out V. So we should get out 180 meters per second to a couple of significant figures. Now, this is quite a tricky question because actually it's bringing together lots of different ideas and going through step after step after step, but it's there as a thing. So have a little look through the rest of the art scheme and do come back to me with any problems. Okay, take care.